Good day, good day, good day. Welcome back to our YouTube channel. If you're new here, my name is Stifler, and today we are on Transverse Pulse. So we are doing waves. This is a series of videos on waves. So we are going to start on pulse, since pulse is a basic building block of waves. So if you enjoyed this content after watching, please make sure to subscribe, like, and also share this video with your mates. It really helps me a lot, and it will also help me to keep on creating videos for you. So let's just get straight to it. So before understanding waves, we have to understand pulse, since pulse are basic building blocks of waves. So we have to understand pulse and also all the properties of a pulse. So I'm sure you have ever held a rope with your friend, where you flick on one side. So you see something that is moving from one end to the other end. So that thing, maybe you're holding a rope here and your friend is at that other end like that. So if you flick this rope once, you see there's something that will be moving like that, like that, like that, like that, like that, till the end. So that is a pulse. So this wave, this rope in which this pulse is moving, we call it a medium. So also in water, if you tap the water, you will see that there will be rings that are moving away from where you tapped. So that's also pulse. That's also a pulse. And if you tap a lot of times, they'll create waves. And also if you flick this rope a number of times, then you see ropes moving and so on and so on. So now let's start with pulse, the basic building block of waves. So now how do we define the medium? So the medium is the substance or material through which a pulse or wave move. So this is a substance or material through which a pulse move. So in this case, we're talking about a rope, right? When you flick the rope, so this wave or this pulse is moving through this rope. So in this case, this rope is the what? Is the medium, because that's where the pulse is moving through. So now let's talk about all that you need to know about the pulse, or the properties that you need to know and understand about the pulse. So maybe before we can go to all the properties of a pulse, let's explain what is a pulse. So a pulse is a single disturbance that moves through the medium. So just like I explained that if you flick one side like this, you have disturbed the rope only once. So if you disturb it only once, you see that a pulse will move. So a pulse is that single disturbance that you have made that is moving through the medium. So all the properties that you need to know about this pulse is this. So we have disturbed this rope, right? We have disturbed the medium. So you see that we have a distance between the rest position and this disturbance. So this is called the rest position. Rest position, or you can call it the equilibrium. So this is the rest position or the equilibrium. So this disturbance from the rest position to this disturbance, we call this the amplitude. So this is the amplitude. So you can describe the amplitude as the maximum displacement from the rest position. So we measure the amplitude in meters, and it is represented by the capital letter A, like that. That is the amplitude. And also the distance of this disturbance, the distance of this pulse, we call this the pulse length. So this is the pulse length, and it is also measured in meters. The pulse length, it is measured in meters. So this is the amplitude, also in meters. It is represented by capital letter A, like that. So let's move on to the first of the pulse that we talk about, the transverse pulse. We need to understand what is a transverse pulse now. So the transverse pulse. So the transverse pulse is a pulse where all particles disturbed by the pulse move perpendicular to the direction the pulse is moving. So let's take a look at this pulse. So this is the rest position. So this pulse, it will move from maybe left to right, like that, right? So as this pulse is moving that way, so it will move that way and so on and so on. It will continue to move that way. But you can see that the particles of this rope are moving up like that. Can you see that? So if you flick it like that, it means that the particles are moving up, while the pulse is moving to that other side. So this is called a transverse pulse, because the particles are moving perpendicular to the movement of the pulse. So they'll be forming a 90 degrees. The movement of the particles are going up. So this movement of these particles is up, while the movement of this pulse is to the right. Can you see that? They are forming a 90 degrees. So the movement of the particles is up and the movement of the pulse is to the right. So we call this the transverse pulse. A pulse where all particles disturbed by the pulse move perpendicular to the direction which the pulse is moving. Can you see that? So that's what we call a transverse pulse. So let's go on and see other properties of this pulse. So, pulse speed. So we know that everything that moves has speed. And the speed, you can also call it the velocity. So we are going to talk about the velocity of the pulse. How fast the pulse is moving. So the pulse speed is the distance a pulse travels per unit time. So we know that when you're trying to calculate the velocity of something, we said velocity is distance over the time. So that's how we calculate the pulse speed. So what is the distance? This is the distance that the pulse has covered. And this time, it is the time that it took to cover that distance. So this distance is measured in meters, and this time is measured in seconds. So every time you're having a distance in another unit, change it into meters. And also if you're having another unit in that is not seconds, change it back to be seconds. So this is how we can calculate the velocity of the pulse, how fast or how slow the pulse is moving, right? So this velocity, the unit of this velocity is meters per second. Meters per second. So let's see how we can calculate the pulses using different questions. So also just know that sometimes you can be given the two of these variables to calculate maybe distance. So as long as you're having these two, you can calculate the distance that the pulse has covered. Or if you're having these two and you don't have the time, you can also calculate using whatever that will be. So right here we're having two situations. So let's calculate. So they said a pulse covers a distance of 2 meters in 4 seconds. Find the pulse speed. So the first thing we write the formula, velocity is equal to distance over time. So the distance covered is 2 meters over the time, which is 4 seconds. So it means that now our velocity can just become 0.5 meters per second. And the second question is saying a pulse covers 5 meters in 15 seconds. Calculate the pulse speed. So again, the first thing is to write the formula. This is distance over time. And our distance is 5 meters over 15 seconds. So this is just 0.33 meters per second, like that. So maybe let's have two more questions so that we'll be fine with this, right? So here we're having the last two questions. They said a pulse has a speed of 0.5 meters per second. How long does it take to cover 25 centimeters? So we can see already that we're having centimeters, so we can change that already into meters. And to change centimeters into meters, we divide by 100. So it means that now this 25 divided by 100 just gives us 0.25 meters. Now let's solve the question. We know that velocity is equal to distance over time. So now we are looking for the time, right? We're having the velocity, which is 0.5, and the distance is 0.25 divided by time. So we can multiply both sides with time so that we can get rid of this time, or we can make it subject of the formula. So this time and this will cancel out, and we have our time times 0.5 being equals to 0.25. Now we can divide throughout by 0.5. So time will be equal to 0.25 divided by 0.5. So that just gives us 0.5 seconds, just like that. So now let's move to the last question. It says a pulse moves at a speed of 5 meters per second. How far does it travel in 2.5 seconds? So now we are looking for the distance. So again, velocity is equal to distance over time. And we're having our velocity as 5 being equal to our distance over our time, which is 2.5. So we need the distance, so we can multiply both sides by 2.5 by 2.5. So that 2.5 can cancel this side. So it means that now our distance can be 2.5 multiplied by 5, which just give us 12.5 meters, just like that. So if you're having a question, don't panic, just state whatever that you're having and see what you are trying to find, and then you can just use the formula to find the unknown. So let's move to the last section of this pulse, and then we'll be done with transverse pulse before we can move to transverse waves. So superposition. Superposition. So suppose you and your friend, again, you are holding the same rope, and then you flick on the other hand and your friend flicks on the other hand. So it means that your friend has generated a pulse and you have generated a pulse as well. So it means that you are here, you have generated a pulse, and your friend over there also generated a pulse. So it means that when these pulses are to meet at the same place at the same time, maybe here at the middle, if they are to meet these two pulses, this pulse number 1 and this pulse number 2, when they meet at the middle, we call that superposition, because they are moving through the same medium and they're at the same place at the same time. So to understand what happens here, like when they meet, we use the law, or we use the principle of superposition. So let's talk about the principle of superposition. So the principle of superposition states that when two pulses occupy the same position, so these two occupying the same position at the same time, the resulting pulse is the sum of the two pulses. So if you want to see how will this react, or what will happen between these two when they meet at the same time at the same place, it means that we find the sum of these two pulses. So the sum of what? Obviously the sum of their amplitudes. So the sum of their amplitudes will give us what results there. So let's take a look at the results. So we have two situations that happens when superposition is taking place. So we have constructive interference. So constructive interference, that's when two pulses meet and form a bigger pulse. So how does this happen? Maybe suppose this side you flicked, maybe this amplitude is maybe 2 meters this side, and your friend flicked again this rope from the other end, and maybe this amplitude is maybe 3 meters. So you can see that these pulses are at the same place there above, right? So when they meet, maybe here in between, at the same time, at the same place, we'll find that the resulting pulse will be the sum of this and that. So it means that 3 plus 2 will give us 5 meters. So it means that our amplitude is now 5 meters. The amplitude of what? Of the superposition, it will be 5 meters. So they form a bigger pulse like that. So after meeting, because this is going that way and this is going that way, so after meeting at the same time, at the same place, they'll both continue to move to their direction. So this will continue to move like that as 3 meters, it will continue to move like that. And that one as well, it will continue to move as 2 meters, it will continue to move that direction, all right? So after they meet, they'll continue to move like that. So we said when they meet like that, they form constructive interference. So now suppose, let's say you are here and your friend is that other end. You formed this pulse of the amplitude that is 3 meters. So your amplitude is 3 meters. And that side, your friend flicked down instead. Maybe his amplitude is 2 meters there. So now when these pulses meet at the same time, at the same place now, just because this one is below and this one is above. So it means that what will happen is that this and this will form a smaller pulse. So this is destructive interference. When two pulses meet and form a smaller pulse. So it means that this one above will cancel out this one below, right? So to find its pulse, it means that this one on top is bigger than this one, right? So you kind of have to subtract this one on top minus that one below. So it will give you a pulse that is just 1 meter long. So this will be your amplitude of 1 meter, because they met at the same time, at the same place, but this one was above and this one was below. So they'll kind of minus each other. So this is the two situations that happens at superposition. It's either constructive interference or destructive. So this is all you need to know about transverse pulses, right? If you have enjoyed this or if you have gained something, please show this by subscribing to our page and also sharing and liking, because it helps us a lot. Please subscribe, like, and share. I'll meet you on the next one where I'll be talking about transverse waves. Have a lovely day.